introduce myself. My name is Manava. So I did my PhD from IISER Pune here in biology. And now I work in outreach or teacher training. So we conduct different workshops where we tell teachers, or sort of not tell, but work with teachers so that they can teach a little bit better. So teaching learning process अजून जास्ती चांगली करण्यासाठी आम्ही काय काय workshops घेतो. Is there anybody who does not understand Marathi? Not completely? Okay, fair enough. I'll speak 90% of the time in English, but maybe 10% of the time I'll switch to Marathi in a little. You understand or no? You understand a bit. No problem. Fair enough. But so this 145 or 130 slot every year is the same picture. That half people are now tired of all the talks and they want to have lunch, or it's too sunny outside. So this is good, but that works because now I can get to interact with you. Because I could see that in the first talks, you were not really talking, right? You were just listening. So now is the time when we are going to interact with each other, and it's easy. It's an easy topic because what am I going to talk about? Water. Everybody is connected to the topic of water, right? So everybody should be able to contribute in this, right? So even before going to water, let's first just discuss a little bit about Science Day. Why? Because let's discuss a little bit about science. Why? Because it's the Science Day today, right? So what is science according to you? Anybody would like to share?
No. Science is something that can be replicated.
Okay.
Within certain conditions.
Okay. It can be replicated if you do it in certain conditions. Any other answers in Marathi will also be welcome. What is science according to you?
That makes human life better.
Okay. So science is anything that makes human life better. Come ahead. I can reach there anyway, so there's no use of you staying at the back. Yeah. What else? What do you think, or what is your perception of science? Yeah, I started, by the way.
Yes.
What? Yes.
Explain the why and the how.
Okay, it explains the why and the how. Okay. Any other answers as to
Asking a question and not sleeping until you're satisfied.
Oh, nice. I like this definition of science. Asking a question and not sleeping until you are satisfied with the answer. I really like this, and I'm going to use this now, henceforth. So, since morning, what all have you seen? Have you seen demonstrations outside? Models? Have you listened to talks? Right? All of these were about some parts or some new kind of theories that people have developed, new applications that people have come up with, new questions that people have answered, all of this. And there is tremendous amount of work which has gone behind coming up with any kind of conclusion that people are presenting to you. There is a certain process by which science happens. So let's start with a very small activity. Can you read the words given in color? What are the question, observation, conclusion, experiment, hypothesis, analysis? Choose a person sitting next to you, behind you, in the next row. Just make a pair and discuss what do you think is the appropriate order of these words. Is the question understood?
Yeah.
प्रश्न कळला आहे का? काय करायचंय? पहिले काय येतं? ऑब्झर्वेशन येतं का, क्वेश्चन येतं का, कन्क्लुजन येतं? त्या तुम्ही शेजारी बसलेल्या माणसाबरोबर तुम्हाला जो सिक्वेन्स बरोबर वाटतोय तो ठरवा. Two minutes. Yeah, I have removed some words purposefully. Yeah, correct. झालं? ठरलं?
Yes.
डिसाइडेड? ठरलं तुमचं? ऑर्डर ठरली? Okay. Is the order, have you discussed what the order should be?
Yeah.
Discuss. I'll give you maybe 1 minute more.
Something like that. Something.
Okay, I think most of the discussions have stopped now, so I think people have come to some agreement. So let's go ahead. What is the first word in your list? Or okay, interesting. Is for everybody the first word is observation? Question. Okay. Now how many people have question as their first word? Okay. How many people have observation as their first word? Okay. So now how do we solve this? It's actually half-half. There is no clear majority. I thought there would be a clear majority towards one answer and then we would say, yes, that's the correct answer. But there is half of the people are thinking that observation, it should begin by observation. Half of the people think it should begin by question. Now the people who chose question, can you give me reasons why you chose question as the first or the beginning of this? Yes. Bolo.
Sites defined as finding answers to a person.
Okay.
Was a differently towards finding a
Okay.
solving the question find it.
Okay. Is that the only way science is defined? Okay. Then I'll ask you another question, that how do you think of a question? How does one think of a question? किंवा मराठीत म्हणायचं झालं तर प्रश्न पडतात कसे? म्हणजे जर आपण प्रश्नांपासून चालू करतोय, फेअर इनफ, पण मग प्रश्न पडतात कसे? हाऊ डू वी कम अप विथ क्वेश्चन्स? व्हॉट शी इज सेइंग, यू सी समथिंग अँड देन यू थिंक ऑफ अ क्वेश्चन. काहीतरी दिसतं आणि मग तो किडा चावतो, असं ती म्हणाली. So that's one way by which we can think of questions. What are the others? How else do we come up with questions? प्रश्न अजून कसे पडतात? ऑब्झर्व, काहीतरी दिसलं, प्रश्न पडला. अजून कशातनं प्रश्न पडतात? एक्सपेरिमेंट मधनं पडतात. बरोबर. अजून थिंकिंग, क्युरिओसिटी. अजून व्हॉट एल्स? How do we think of questions? How do we come up with questions? What makes us question?
So
all of that. Observation. Yes. Thinking, curiosity, experiment are the answers. What else? What else makes you question? Curiosity, yes. So I'll repeat the answers which have been given till now. Observation, curiosity, experiment, thinking. What else? Correct. So again, curiosity or thinking maybe. How else do we come up with questions? New questions or questions? Yes.
a question leads to another.
A question leads to another question. Nice. What else? Dissatisfaction with the answer leads to another question. What else? सो फॉर एक्झाम्पल, आपल्या इथे आधी आत्ता, मी तिचं नाव आत्ता विसरले, तिने ॲस्ट्रोबायोलॉजीचं तिचं काम सांगितलं, राईट? गौरी. येस, गौरी पत्की. येस. सो शी स्पोक अ लॉट अबाउट डिफरंट क्वेश्चन्स इन ॲस्ट्रोबायोलॉजी. हाऊ डिड शी or her boss come up with those questions? What is the one major thing that we are missing? That is the curiosity of the unknown. Yes. But not everybody has the same level of curiosity of the unknown, right? Yes. By learning new things, yes, and by reading. By reading, that's how we come up with new questions. So we read about work done by other people, and that raises new questions. So there is no correct order as such, right? So it can be like this, as most of you thought that it can be question, hypothesis, experiment. So I think, yes, you were discussing the first one. Then half of you actually thought this one, right? That it starts with observation, then there is a question, and so on. If you look at it, there are actually, you can draw arrows in all different ways. Because many a times, from one conclusion, you can come up with another question. Or you can come up with a new hypothesis. Or some analysis can lead to some other question. Or mistakes in either of these can lead to some other questions. Right? So actually, it's more like a cycle. It's not really a linear process. And that is how science functions. It can be, you have to do a lot of steps. Many a times you have to repeat the steps, come up with alternative ways of doing things. That is how science works. And as even since morning people are saying, that's why it's a collaborative journey. It's not the work of one person alone. So all of the scientists or all of the people who have spoken to you so far have been saying the same thing, that they work together with a lot of people to come up with all of these things, right? So I just wanted us to go through this whole process, and now we can go back to our topic. Now this is the riddle for you. You know what is a riddle? Yes. Can you read? Can everybody read? Yes, you know, of course, that's my topic also. This was an easy one because my topic was water. The title, you know. But now this one is a little more difficult. Okay? I can fall from the sky, yet I never touch the ground. I can cover the earth, yet I make no sound. I disappear in sunlight, but I return in the night. Water doesn't disappear in sunlight, huh?
Water.
Moonlight? Clouds could be an answer, but I'm looking for a...
What?
Again, clouds and water vapor is close by.
But what's the point?
क्लाउड्स मध्ये वॉटर वेपर सोडून अजून पण गोष्टी असतात की नाही, नुसतंच वॉटर वेपर नसतं. येस, somebody said it correctly. So what is the answer? It's fog. But again, cloud is close to it, and even water vapor is close to it. I travel the world, but have no feet. I touch the shore, then I retreat. It's easy now. I rise and fall, I obey the moon. Correct. Without my rhythm, ships would be doomed. So, ocean or tides or, seas. And the last one. Yes. Perfect. So, now you know what I am talking about. So where do we find water? We find water in oceans. We find them in rivers, in streams, in rivulets, in lakes, in ponds, in puddles. Where else? Whose body? Everybody's body. And where else? Atmosphere. And where else? Earth. Inside the earth. Yes? Yeah, that's what we call groundwater. Yeah.
It was.
Aquifers inside the earth, or there is so much of water beneath the ground, which we can say pretty much everywhere. In all the organisms and everywhere around us, we have water. So today we are going to talk a little bit about the chemistry of water, the physics of water, the biology of water, and more importantly, the sociology of water. See, it's an important topic that matters to each and every person, each and every organism, each and every tiniest thing on the earth, as well as, so we all need to know a little bit more about water and need to be a little bit more sensitive about water, right? So let's first discuss the chemistry. We all have seen these diagrams before, yes? So, school children, what is water made up of? What kind of a molecule is it? Are you in school? Hydrogen and oxygen. How many hydrogens? How many oxygens?
Well,
Two atoms of hydrogen and one atom of oxygen. How do you know this? Yeah, how do you know this information?
the type.
Science textbook? Huh? Yes.
Oh, there's like that.
Correct. But how do you know this is the question. For you, the answer is simple. It's printed in my textbook. Correct. But there must have been a time when people did not know this. Water was there. They were drinking water. They were using water. They were probably bathing with water. There were ships also, or maybe primitive things or whatever. But they did not know that it is H2O. And even without that knowledge, everything was functioning well. But people then came up with a systematic way of studying things and eventually understood that yes, there is something, there is hydrogen, there is oxygen, and this is the molecular makeup of water and all of these things through the process of science, right? Formally, informally, but eventually they must have done all of those: question, hypothesis, experiment, analysis, conclusion. They must have gone through all of these steps to generate all the knowledge that is now there in your textbooks and that we easily take for granted. Simplest example being water is H2O. But there must have been, see, water was always like this, but people did a lot of things to make sure, to find out that this is what water is. And then based on this, a lot of other properties were studied and the properties were exploited in the sense that they made use of a lot of different properties of water. Okay, so can you read this? The oxygen atom pulls the electrons more than the hydrogen, making water a polar molecule. So you must have heard these words before, that water is a polar molecule. Do you know what is meant by polar? Yes? There is some, so there is a small negative charge on the oxygen and a small positive charge on the hydrogen, right? And this polarity is what is very important in forming a structure called as hydrogen bonding in water. See, that is the reason why water molecules are always trying to stick to each other. Okay, they're trying to form a drop or a spherical shape because they have a property called as hydrogen bonding, which sort of makes them stick to each other. So that is also one of the reasons why it's a very powerful solvent. What do you think this is?
Sorry?
Salt. Why do you think this is salt? Exactly.
Is right.
Any other clue which will tell you that it's a salt? It's salt that I'm talking about. On the slide, you can see that there is Na and Cl, which is also the salt, right? So this is showing how the salt is actually dissolved. So when you add your salt meat, NaCl, in water, what happens is the sodium and the chloride from NaCl separate and these water molecules sort of form boundaries around them. And because water molecule is also polar and Na and Cl are also polar, they can form these structures. So water has the ability to dissolve a wide range of solutes. Or आपण साखर टाकू शकतो, मीठ, लिंबू, बऱ्याच गोष्टी विरघळतात पाण्यात, बरोबर? So water has the ability to dissolve a wide range of solutes in it. So now the best question, which I really like, what is the color of water? Colorless? Sure? Then why are the oceans blue or sometimes green? Reflection of exactly what?
The sky.
Sky. Is it the reflection of the sky? The sun's light? Huh.
Like the lights on the voltage spectrum.
Different lights from the, which exactly?
In what? Wow.
The light can go to the ground, so the light can travel to the ground, so the ground can't glow, so the water we see is green or blue.
Okay. More answers? मराठीत सांग.
पाणीच्या आतमध्ये लाईट जाते, पण ती जमिनीपर्यंत नाही पोहोचू शकत, त्याच्यामुळे अंधार असतो आणि मग अंधार असल्यामुळे मग ते अख्खं आपल्याला ब्लॅक किंवा मग असं ब्ल्यू वगैरे दिसतं.
अंधार असतो त्याच्यामुळे ब्लॅक किंवा ब्लू दिसतं असं.
हां.
असं उत्तर आहे. एनी अदर आन्सर्स?
wavelength of the light that passes through makes it blue in color. The wavelength of the light that passes through the water makes it blue in color.
So it makes it blue in color. So upon this is important. This is very important. It does not make it blue in color. So if it would have made it blue in color, आपण पाणी उचललं असतं तरी आपल्याला ते निळं दिसलं असतं. तसं होत नाही. Right? When we look at any ocean or any water body, it appears to be of very different colors. Sometimes blue, sometimes green, sometimes brownish. Plenty of different colors, but water itself is pretty much colorless. There are multiple reasons why the water appears of so many different colors, and we are going to see those reasons right now. But first I want to ask you an important question. So these are the different colors which can appear when we talk about the color of water. But first let's discuss, why do we see any color at all? Yes.
The seeing color represents reflection of the light of that.
Reflection of light of that color? That same color are we talking about?
Or there's a light strikes in an object and it absorbs all the colors except the.
Okay. Exactly. Correct. So now maybe we can think a little bit about what color is my kurta? Red, right? So right now, as you have rightly said, when you look at any white light or visible light, it is composed of many different wavelengths, right? It's a mix of all of these different lights, which we commonly also know as the rainbow colors or Vibgyor or Tanapihi Nipaza, and many more in between also. So these are the visible or the light, the kind of wavelengths that are visible to us. Those are in the range of 400 to 700 nanometers. So whenever something, any kind of light, or whenever this white light falls on any object, what happens is there is some amount of absorption and some amount of reflection happening. Depending on how much or which particular wavelength is absorbed and which is reflected, that is going to decide what is the color that we are going to see. Whichever object we are talking about, right? So let's have a look at an example. For example, in the first figure, what do we see? All the colors of the white light are falling on this surface, but that surface is a black surface. Why? Because most of it is not reflected. Most of it is absorbed. Such a surface is what we call a black surface, right? हे असं होतं म्हणूनच आपण त्याला काळं म्हणतो. आपण कधी काळं म्हणतो? कारण त्याच्यावर लाईट पडल्यावर मॅक्सिमम ॲब्झॉर्ब होतं आणि रिफ्लेक्ट काहीच होत नाही. त्यालाच आपण काळं म्हणतो. तेव्हा तोच काळा रंग असतो आपल्यासाठी. सिमिलरली, what is a white surface where most of the light that falls on it is reflected. Now, when would you see a red surface, or when would you call something red? जेव्हा रेड सोडून सगळं अब्झॉर्ब होईल. ओके, आता मला सांगा पाणी निळं का दिसतं? So have a look at this. So I'll show you one more diagram. Have a look at this, where you can see why this appears green or why this apple appears red. Now think, why does water appear blue in oceans? All other than blue. Okay, yes, it absorbs all the other wavelengths other than blue. But there are plenty of other reasons or plenty of other factors which affects. It is not as simple as just this, absorption and reflection of the blue wavelength. But because there are plenty of solids dissolved in water, it matters from where you are actually observing. What is the depth of the water? How much pollution there is? What is the temperature of the water? Because the behavior, the absorption and reflection behavior is also going to change with temperature. So plenty of different factors affect how we are actually going to see the water. But this was more about the chemistry, or should I say physics? Was this also physics related? Of course it was. So when you talk about light, you talk about energy, you are not simply talking about the chemistry, you're talking about the physics also, and eventually you're talking about the biology also, right? So let's talk a little bit about the physics. Now you must have seen this video. Okay. How many of you have seen a video of a needle on water? Nai? Nai. Bar. Ha. Sui. Needle is sui. कशाची बनलेली असते सुई? मेटल. मेटल पाण्यापेक्षा जड असतं का हलकं असतं? तर सुई पाण्यात टाकल्यावर काय होईल? सिंक. ओके. आता आपण पोल घेऊ परत मगासारखा. मेटल पाण्यात टाकल्यावर, मेटलची सुई पाण्यात टाकल्यावर काय होणं अपेक्षित आहे? व्हॉट डू यू एक्सपेक्ट विल हॅपन व्हेन यू पुट अ मेटल नीडल ऑन वॉटर? Sink? How many of us think it will sink? Okay. Let's see what happens. Oh, yes.
We are spent.
Okay, now the video will play. What happened? It's floating. I also, when I initially thought about it, I also expected it should sink. It's a metallic thing. It has some weight. It has some density. And we are putting it on water. But even then, it is sinking. Right? That is happening because water has some really cool properties called as adhesion, cohesion, as well as the most important and which we use to a large extent in a lot of applications, which is called as surface tension, right? So what can you see? Adhesion and cohesion. So here you can see that in cohesion you can see two same molecules are coming together. So the forces of, yes, bolo. Sure.
The needed total water, but is there a certain level of water at which like we can decide any amount of water above that amount of water that needed?
Yes, but it's quite intuitive in the sense if the water is really like just a few drops, of course it won't work. But other than that, I don't think whatever you think logically that, you know, a little bit of water, that will work. You don't need like a really huge amount of water is your question, right? So no, as long as there is at least, Jasmine, is there a particular, yeah, no, no? Yeah, yeah, yes. Huh. Exactly, that's it. So she's Jasmine and she performed a lot of activities today with students on exact same principle. And I think the students enjoyed it a lot. So yeah, just a little amount of water which is stationary, something to, but you can, everybody should definitely try this. You can also try this using paper clips. U-clip, paper जोडायची U-clip पण वापरू शकता, कुठली पण needle वापरू शकता. So this mainly happens because of a property of water called as surface tension. Now here you see at the, whenever there is, so there is water in this container, right? So there is water here at the edges. So at the edges also, water molecules are interacting with the glass or the steel or whatever. There we are talking about adhesion because water is interacting with some other material. But whenever two water molecules are interacting with each other, we call it as cohesion. And the best part is at the surface. So here, on the topmost layer, there will be a situation that the water, there is nothing, there is air on top of that. In that scenario, the cohesive forces are quite strong and water essentially forms a very tight layer and almost like a membrane. And that's why the needle floats. because the water molecules on the surface are quite tightly packed with each other. They behave almost like a membrane and they don't let that needle go through, even though it is heavier, and that is what we already expected it to do. But I would encourage all of you to try doing that, because even though you expect the needle to float, it's not easy to do that either, because the water really has to be stationary. So try that at home. So this is exactly why, or because of the property of surface tension, this particular insect called as water skater, can actually, it almost appears as if it is skating on the surface of the water. Okay, right? It is walking on the surface of the water. That is possible only because water has a particularly high surface tension as compared to any other fluids. And we also make use of a lot of these properties of surface tension of water in multiple applications. So this is also how or why the water drops and water bubbles appear the way they are or the way they do. Now just imagine how would a bubble or a water drop look like in space. I am talking about surface tension. I did not talk anything about gravity, right, in the earlier slide. I only talked about surface tension. But now I am asking you to think a little bit. What do you think happens to the shapes of bubbles and drops in space? So here you can see, so this is very interesting. In fact, this is where an air in a drop, or rather an air bubble, is trapped inside that of water. Here we would never see something like this. It wouldn't stay in that format. It would immediately burst, or smaller bubbles would be formed. But here, because in space there is no gravity, it still continues to stay like that unless you do something to it physically. Automatically it is not going to dissipate or form smaller bubbles. So that's very interesting. So even though we are talking about surface tension, we always have to keep in mind that whatever we are talking about applies to Earth, where there is a certain amount of gravity, right? Last one. I promise this is the last one. Ice. Correct. So you know this also. Why does ice float on water? Does ice float on water? Yes. Bolo.
It's water. I can't here. 40.
Hmm.
I said, doctor. And I found that others do.
Okay. So.
Oh, ice. Ice, that's
Hmm.
lower than 40.
Okay.
Stay to these stars degrees below.
Okay. Okay.
Was that there tonight? And what? I so start to get it.
Correct. So you have explained most of it absolutely correctly. That why does, so what is it that makes ice float on water? So on reaching a solid state, the hydrogen bonds, which we saw in the first couple of slides, start arranging themselves so that the water molecules actually move far apart from each other. So the volume actually increases, but the weight is not changing. And that's why the density becomes lower as compared to that of water, and it floats. And there are amazing things which happen because the ice can actually float. Life can flourish under the frozen surfaces of water. So there are many lakes or mountains, glaciers, not mountains, glaciers, lakes, which are frozen, but even below that, there is still water which is not frozen because the ice floats on top, and there is so much of life in there, right? Life can be sustained even in that area, and this floating sea ice is very important for the circulation of oceans all around the world. So these amazing properties, made by chemistry, made by physics, or these are the properties which actually result in water being the best possible medium to where life was created. And that we saw in the earlier talk also, how actually first molecules could have been made, which were made in water. So we drink water, we almost 60 to 70% of the human body is water. It helps with so many different processes. All organisms need water, and life probably originated also in water. So all of these properties of water may be chemical or physical, like polarity, density, high heat capacity, the fact that it's a very important solvent, the cohesive and adhesive properties, all of them have resulted in the life, basically. Water or life can be sustained in water because it has certain chemical and physical properties. So there are so many living organisms which survive in water, but all living organisms need water in one way or the other. So some very important facts or some interesting facts, that the same amount of water on earth is there right now as it was when the earth was formed. So come to think of it, you might be drinking some water molecules which someday some dinosaur might have, actually consumed. We don't know. There's no way of knowing, but it could be true. And nearly 97% of the world's water is salty. 2% is otherwise undrinkable, so only 1% is available for human consumption, for all our needs, right? Water also regulates the earth's temperature, and a person can live about a month without food, but only about a week or even lesser without water. There are severe consequences of dehydration. A simple test of dehydration is try pinching yourself. Try pinching your cheek. Okay, I like your expression. You're just waiting around to see if other people are doing it and then she's doing it. So if you pinch and the skin immediately comes back to normal, you can pinch your hand maybe to see. That means you are not dehydrated. If you feel that your skin is, taking a little bit longer to come back to normal, सुरकुत्या दिसतायत जरा, तर पाणी कमी पिताय आणि जास्त पाणी प्या. Okay? Yes. So because of all of these things and because we know that we need water, what we need to do is focus on these two points because these are very important. So if you see our country's projected water availability per capita was 1486 meter cube in 2021, and it is expected to decline to 1367 meter cube by 2031. I'm sorry, I missed out 2031. Look at the global average. Global average is 5500. That means all around the world, or the global average is this much water is available per capita. In India, it's just this much, and it is expected to go down to this much in 10 years. Right? So India is on the path to becoming severely water scarce country. We are already facing a severe water shortage, and we are on the path to becoming even more, we need to worry more, because 16 to 17% of our population, of the world's population lives in the country, but only 4% of global fresh water is available, right? So we are already facing a water shortage. So what can what can we do to save and protect the water? What can we do? Right from what is the smallest thing that you can do right at home to bigger things also. What can we do? Yes? Not to waste water. How will you not waste water? What will you do to not waste water? Okay, yes. Excellent.
So, not use excess of.
Not to use excess of water, yes. Don't take showers or don't take long showers. Don't take showers. Don't take showers, yes. Don't play with the water, okay.
Don't use shower.
Don't use shower. Okay. Use a bucket, okay.
And while washing your cars, use a bucket and the sponge.
Okay. Very important. Yes. Yes. She said something very important. Don't throw garbage in the water. Right? So, all of us can do really small things, especially at home, and I love the fact that the youngest of the crowd had most of the solutions and most of the answers. So that is amazing. So all of us can... So all of us, and that is what happens, right? We all learn all of these things right from our first standard, but somewhere down the line we forget about it. So we need to keep telling ourselves that we need to do something about it. We need to be responsible for our own water. Nobody else is going to come and do that for us. It starts with the small steps, like all of the things which our little friend suggested, but also we have to worry about the pollution of the water. And at the level of the government, they are also trying to come up with different solutions, but let us today decide to do whatever small bit that we can from now to save and protect our water. Okay? So that's all from my side, and this is very important. I really like this. No water, no life. So no blue, no green. If our blue water is not going to be there, the green of life is not going to be there. So we need to worry about the blue so that the green can live happily ever after. Okay? Thank you so much, everyone.
Yes.